All right, so the first thing that we're going to go through is a couple of just background items here. So we are talking about dynamic audio processing today. Oops, let me go back here. What this is, when it comes to dynamic audio processing, it's a lot like what we talk about in gain structure. What we're going to go over is really some best practices. These are not the only way to do these things. There's always multiple ways to come to the same conclusion, to end up in the same spot. So what we're going to be showing today is really just what we've nailed down as sort of some best practices for using some of these blocks and for interacting with some of these items. We're going to go over compressors and limiters. We're going to go over expanders and gates. And then we're going to touch on automatic gain control and continuous ambient compensation. And we'll be showing these live inside the software when we get to that point. So the first thing we want to talk about, what is dynamic audio processing? What are we even talking about? Well, the first thing we need to address is what we call the dynamic range of an audio signal. So, and when we talk about dynamic audio processing, what we're doing is we're changing the level of a sound over the course of its lifespan. What you end up seeing in this graphic over on the right is a demonstration of dynamic range. So dynamic range is the difference between the sound's loudest and quietest moments. This is exactly what we're going to be working with in these processing blocks. Is we're going to be working between these 2 points. So we're going to be working inside this dynamic range. Types of dynamic audio processing. All right, so for the most part, the names of the processors will refer to what we're doing to the dynamic range of the signal. So we're going to deal with 4 main types today. We're going to talk about compressors, limiters, gates, and expanders. So, and again, like I said, we will also touch on AGC and CAC. So the first thing we want to do is we want to go over some terminology. As we go through these blocks and as we start looking at them and really digging into their controls and what they do, we need to understand some of these kind of basic terms before we move through them. First thing we're going to talk about is the threshold. So at what level are we beginning to affect the signal? This is referenced in dB or decibels, and this all relies on proper gain structure to be fully effective. And that's going to be a common theme through most of these, is that these all rely on having good gain structure on the front end to make sure that we can effectively manipulate these dynamic ranges. If our signal is too high and it's getting clipped out, then we're not going to get all of the dynamic range because we'll be losing a lot of the high part. If the signal is too low, then we may not be getting all of the lower end of the dynamic range. So if you've taken our best practices in gain structure, you'll know a lot about that. If you haven't, I highly recommend doing it. That is really the intro or the first part of making sure that you can effectively manipulate the dynamic range when you get inside. All of what we're doing is going to happen right after you've set your dynamic or your gain structure. So now that we've talked about threshold, let's talk about depth. When we're in compressors and expanders, this is going to be the maximum amount of attenuation that's able to be applied to the signal. When we're dealing with gates, this is going to be negative gain that's applied to the signal when it's below the threshold. And again, we're just kind of talking through these. I'll show you exactly what these mean when we actually get into the system. All right, the ratio. So this is the ratio between the input and the output as measured from the threshold level. So the closer we get to a ratio of 100, the smaller the dynamic changes are in the output level. As your ratio gets back closer to 1, then the dynamic range of the output increases. Once you get to 1-to-1, that basically means what's coming in is what's coming out. So you're really not doing anything on the block. Okay, a soft knee. When we deal with compressors and expanders, You'll notice that sometimes you'll see what's called a soft knee. This is a smoothing of the transitional curve as we go from above and below the threshold. When you're in a compressor, it's when you're going from above to below. And then when you're an expander, it's when you're going from below to above, since they work on opposite sides of the threshold. A soft knee of 0 is essentially just a squared off, pretty standard knee, much like a limiter or a gate. A soft knee of 24 will spread that attenuation, and it's all above and below the threshold. So a soft knee of 24 will go from 12 dB below the threshold to 12 dB above the threshold. So it just curves that out based on the setting of the soft knee. Attack time. This is the amount of time that it takes for the block to kick in and begin working. It is, if you want to get super technical when you're setting your attack times, it is technically the amount of time that the block takes to reach 63% of its desired dynamic range. So almost 2/3 of the way to where you want it to get. That is the time that is referenced in attack time. Release time is the opposite of the attack time. This is how much time it takes for the block to stop working or release the signal. Again, specifically, it's actually the amount of time that it takes for the block to get back to 63% of the initial level. Hold time. This is the amount of time that it will keep the applied gain unchanged once the signal drops below the threshold or the block is disengaged. This is in gates and AGCs, and this helps smooth out the operation so it doesn't feel like it's getting super choppy. You can put that hold time in there so that it will stay at a certain level, even with little fluctuations above and below the threshold. Detector time. This is a way to delay the detection of the signal above or below the threshold. This is if you want to kind of slow down what's going on, and you want to have momentary spikes or dips in the signal from activating activating the block. This can be set as a static value in the properties when you first set up the block, or it can be set to a user-controlled value inside the block once it's running. If you turn on the user-controlled, then that means you can actually change it live and really help dial it in. I generally recommend turning on user control, but I will show you how that works. Okay, on to the demo. Let's look at gates and expanders. All right, so this is the first thing that we're going to look at for today. Compressors. Oh, damn it, I'm on the wrong screen. There we go. Gates and expanders. Man, I'm going to get here eventually, I swear, guys. Okay, so here's why I grouped gates and expanders together. What these are going to do is these are both going to affect the signal's dynamic range below a set threshold, okay? So if the signal is above the threshold, it passes unattenuated, it's all well and good. If the signal is below the threshold, then it's going to be attenuated by the amount specified in the depth control. The gate is essentially an on-off switch for the signal. If you set it improperly, you're going to hear it as really choppy audio. If you've ever heard a gate that's not set right, you will know exactly what it sounds like. It sounds like somebody put a speaker above a ceiling fan. The gate block also has an open LED. So when it'll light up or it'll go high when the gate is open, and you can use this to drive logic elsewhere in your signal. The expander is essentially the same as a gate, only it has a ratio and a soft knee setting, so it's not quite as choppy as a gate. If you are familiar with using some of these blocks in a mixing environment, like if you've ever done live mixing or studio mixing, sometimes you will hear the terms upward or downward expanders or compressors or anything like that. If you know what I'm talking about, then this next 5 seconds is for you. If you have never heard these terms, then stick your fingers in your ears for the next 5 seconds. But just know that QSC is actually using what are typically referred to as downward expanders. That is to say that we are always attenuating the signal when it's below the threshold. We do not amplify the signal above the threshold. So gates and expanders are used to filter low-level sounds out of your final mix. If you have, say, some static room noise, or say you have some noise from an AC or a projector that's close to your mic, you may want to use a gate to keep those low-level noises from passing through. If you have multiple mics close to each other, you may want to use an expander so that you can just focus on the strongest signals from and keep some of the lower ones out of the mix. Gates and expanders are almost always used on the input side of the signal chain. So the $1 million question that everyone will ask at some point, most likely, is when do I use a gate and when do I use an expander? Honestly, that is a personal preference thing, and it changes kind of by scenario. If you want that smooth transition when it goes from being closed to open or open to close, then you'll be wanting to look at an expander because it's got a knee on it. If you want to use hold time, or if you want to drive logic down chain and know whether it's open or closed, then you would want to use a gate. As you experiment with these and you learn their differences, then you'll learn, you'll get more comfortable with which one to use. Just know that you're not going to use both in the same signal chain. Pick one. So as we see in our little example up here, we've got our input, we've got everything is set to our proper gain structure. We've got a little high pass, low pass, and a parametric on there. And then we've picked either a gate or an expander. So let's go down here and we're going to look at this. So we're going to see our gate. And what you'll notice is we are above the threshold. Our threshold is set at -30. For any of you that may be unfamiliar with using any of these blocks in Q-SYS, they are very handy. So here is our threshold, here is our depth, but you will also notice that these appear on the graph. And if you grab these dots and move them around, you can notice that our threshold is going up and down. So you can use these to fine tune if you want. So here we've got our threshold. Here's our depth way down here, because we're saying if we're underneath that, we want to just completely kill it. And what you'll notice is as this signal goes down, now you'll notice that we are applying -60. That is our depth. And you will also notice that our open is now false. So as we were talking about earlier, here's our attack time and our hold time. We have a 1 second hold, which is why you'll notice that once this opens, even when it trickles underneath, it's a 1 second before it closes this. Our release time is 100 milliseconds, and that is how long it takes for it to completely slam shut. So as we turn this back up and we go back towards full signal and we are above the gain, then you will also notice that we are we're showing that we're open. So now we've got our logic high that we can pull out of a pin, or if you wanted to script something, it's just a way to see whether that gate is open or closed. On the other side, we have our expander. We're above the threshold, everything's happy. This is very similar to what we were doing over here on our gate. But you will notice that as we turn this down, we get this soft knee. Here, I'll actually kind of zoom in so you guys can see this a little better. You'll notice we get this soft knee right here. And you'll notice as I turn this up and make the knee bigger, that it smooths out this ramp. And like we said, at a 24 knee and a threshold of 20, which is actually right here, you'll notice that we are 12 above and 12 below where we actually start working. So this is going to show the threshold is at -20, even though we see that it actually starts to manipulate the signal because we've got a ratio. And you'll notice, remember what we said, as we get closer to a ratio of 1, what happens? We just smooth this thing out. Nothing's going on. You can see that in the graph. But at a ratio of 100, we're pulling it out. It's basically working very similar to the way a gate would work. Only difference is we can work with a ratio on this side. So we'll set this out. You can see that shortens up this curve right here. And that is compressors and expanders. And if I could find my Zoom window, which eludes me at this point. Okay, there it is. Now I can see that I don't have it. I'm trying to open my Q&A so that if you guys have any questions, I can see that you guys have questions. All right, so moving right along. Now that we have looked at gates and expanders, let's move on and talk about compressors and limiters. And by the way, I didn't say this beforehand, but you guys will get in a couple of days, you'll get an email and it will include this designer file. And it'll include the music file. There's a music file and a speech file that are on here that I'm using to generate these and play with. If you hook it up to an output, something will actually come out of a core. You can manipulate it if you will. Here's all the audio blocks over here. So you can actually put this and load this onto a core. This is just using an audio player. And you can start to hear how these actually work. So let's move on to compressors and limiters. So these two blocks will affect the signal's dynamic range above the threshold. So our gate and our expander, those were manipulating the signal below the threshold. Now we're above the threshold. Compressors and limiters can be used either on the input or the output side, and I'm going to show you how that works. And they often are used together. So like we just said earlier, gate, expander, pick one. A lot of times you will see people use a compressor in front of a limiter. The limiter is pretty much a hard stop to an increase in gain. Once the signal hits that threshold, it will not get any louder. You'll use attack and release times to determine how quickly that block works. You can think of this kind of as the opposite of a gate. The compressor performs the same function, but you get the added controls of ratio, depth, and a soft knee. So you can think of a compressor as the opposite of what we just saw in an expander. So the ratio will determine how much gain is increased at the output level relative to the gain at the input. If your ratio is set to 4, which is the default value, it will require a 4 dB increase in the input level to result in a 1 dB increase at the output. That's how the ratio works. The closer you get to 100, the more the compressor will work like a limiter. A ratio of 1 to 1, as we've discussed earlier, means the block is doing nothing. The depth will set the maximum amount of attenuation that can be applied to the input. So as the input increases, the compressor applies more attenuation based on the ratio setting. And when the amount of attenuation reaches the depth setting, no more attenuation is added. The soft knee just smooths off that transition as the input is increased. So let's look at this in a real world scenario. We're going to use this as an input processor in this case. So we've got our flex input, or we've got an input coming in. We're running that through our high pass, low pass, and our parametric, and then a limiter, and we are protecting our signal from overdriving at the beginning as part of our gain structure. So say this is a microphone. We've got loud talkers and quiet talkers, but we want to make sure that if somebody gets on and is really loud, that they don't just start blowing everybody out of the room. So we're going to put a compressor and a limiter on there, and we're going to set that so that it doesn't get crazy. I have also used this in hospitality environments on cable boxes and satellite receivers. This can help keep commercials from coming through really loud by just taking the top off of them. I've also done that with AGCs to smooth out the differences between programs and commercials and stuff also. And I'll talk about that when we get to AGCs. So the other thing I'm going to show you is if you're using the analog outputs on a core. So you've got your room gain, you've got your room end, and this is going to protect your analog equipment on the back end. We talk a lot about in compressors and limiters, we talk about using them for protection on the output side. So typically you would put the compressor before the limiter to smooth it off as it starts to get above that threshold, and then the limiter's your catch-all on the back end. One of the things that we do recommend when it comes to limiters is setting them at -2 or -3, and I'll show you why that is when we actually get in there. But this is how this would be used on analog processing. If you are lucky enough to be using CXQ amps and some of our speakers, say our AD series speakers, you do not need to put a limiter on there, because our speaker processing block that goes on the output side, that is this block right here, that has intrinsic correction as well as built-in limiting for the amp for that speaker. So save yourself a little bit of DSP power, put that on, and there's no reason to put a limiter in front of that because there's already a limiter that occurs inside the amplifier for that signal. So moving along, let's look at our compressor and how that works. So I'm going to turn on the compressor. I'm going to turn this up, and you'll notice that as this signal gets higher and starts trickling above the threshold, we are applying negative gain. So we are turning 4. So for every 4 dB above the threshold, we're only allowing it to go up 1. So for every 4 dB above, we're actually taking 3 dB out. So that's what you'll see. If this is trickling up somewhere around -12, then you should be seeing around -9 on ratio works. And just like we talked about before, the higher you turn this, the flatter this curve gets, which means it now takes 11 dB above the threshold to even get 1 dB above. And then as you get this back towards 1, now it's not even doing anything. You'll notice there's no applied gain. So same thing with the soft knee, that just rolls it out. If you go to a soft knee of 0, then that's just hard. As soon as it hits it, it hits it. As you get closer to 24, that's 12 above and 12 below. You'll also notice that this kind of smooths out just a little bit. But really, that's just something that you'll want to play with as you work through. Our detector time, we talked about how that can either be set or it can be adjustable. We have set this to user setting, so our detector time is actually settable or is actually changeable. Yeah, so David, I'll cover the AGC versus the expander here in just a second, and I'll tell you why. I'll tell you what the big difference is on that. Okay, so so this is our compressor. This is what our compressor looks like working. I'm going to turn this off, and I'm going to turn our limiter on. Looks like I'm between tracks, maybe. Okay, switch over. Maybe this is back up. All right, so here's our speech track. We'll look at our speech track for a second. So what you'll notice about the limiter is that it is just a hard off. There is no curve. It is just like throwing a switch. Whenever it gets above that threshold, nothing else goes above it. You'll notice mine is set to about -5. The reason mine is set that way is because there is detection time and attack time that is involved in this. There is an inherent, even though it's a very small amount of time, there is an inherent delay from the time that it takes the block to sense that it is above the threshold and actually slam that door. So The reason we suggest that you set it -3, -2, -5, just kind of depends on your scenario, is to allow for those momentary spikes above the threshold before the block grabs it and slams it back down. This is important if you're setting limiters up on analog outputs to keep from clipping or overdriving whatever you're feeding. It can also be important on inputs to keep yourself from getting a clip at the input side of things. So as you can see in this, what we've got is we've got our limiter. It's working. We can put our compressor in line as well. And you'll notice that our threshold on catch before the limiter does. You're using this to kind of smooth out anything that goes up above our threshold, and then we're using our limiter just as a catch-all at the very end. You know, and if everything goes well, we don't really trip the threshold on our limiter. But in this instance, we are purposefully just pounding signal into it so that we can see them work. So. All right, any questions as we exit compressors and limiters? Turn this back down so I'm not just banging into the end of these. All right, turn these off. The last thing we're going to talk about is AGC and CAC. So AGC is automatic gain control. This is used to add or subtract gain as the input signal fluctuates up and down. So to answer the earlier question, what's the difference between an AGC and an expander? An expander can only take gain out. An AGC can actually put gain in. So that's why you may want to use an AGC. AGCs are very touchy. They take some time to really get used to. But when they are used and you get one really dialed in, you will notice that they work quite well. The things that you want to pay attention to are going to be your threshold level. So this is going to be the level at which the component becomes active. This should be set so that the ambient noise of a room won't trigger it, but the signal you're looking for will, if you're talking about using it on a mic. The target level, this is, let me zoom in on this. I realize this is kind of hard to see. There we go. So the target level, this is the level that you're trying to achieve all the time. This is going to be the point from which the gain is calculated based on your ratio setting. So if your level is below the target, you will apply gain. If your level is above the target, you will apply negative gain or attenuate. Maximum gain, this one is very important. This is the maximum amount of gain that can be added. Now, understand this has nothing to do with how much gain can be removed or how much attenuation. You can go as far down as you need to go. This is just capping how much you can add. This becomes very important if you are using this on a microphone, because you don't want to give it more than 2, 3, maybe 4 dB, because you don't want that mic ramping itself up so high that it starts feeding back in the room. So the ratio is the same concept as the other block. Typically, you'll use an AGC with a ratio of 100 because you want to be pretty consistent across the board. But there are some times when you may want to lower that ratio, but then it's kind of just going to act like an upward compressor more than it will an actual auto gain control. But if that's what you're looking for, the control is in there. All right, so the last things that we'll talk about are time constraints. We have some time constraint controls down here. So the response time, this is how long does it take for the gain to get from its current level to the new level once we detect that it needs to be changed. The other thing we can do on this is we can enable the recovery settings. This is going to, if recovery is enabled, then recovery time and hold time will now become active. Hold time is going to set the minimum time that the applied gain stays at the calculated level after the input level drops below the threshold. This is especially helpful if you are working with microphones and somebody stops for a second or two. You don't want that to start to recover and then they start talking and now they're either too quiet or too loud and you got to wait for the block to kick back in again. So I like to use a little bit of a hold time. And then recovery time is the amount of time that it takes for the gain to reset back to zero. This also helpful when you're dealing with signal levels that may change or stop periodically. You want to kind of slow that down a little bit to smooth out those transitions. Things to remember: an AGC is not a cure-all. This will not solve every problem that you have in big, broad dynamic swings inside of a signal. What it can do is help you smooth some of them out and keep you from having big like peaks and valleys and keep your customer from having to run over to the level control every time something changes a little bit. They can be used on BGM sources to kind of smooth out the differences between songs. They can be used on microphones to help compensate for loud talkers versus quiet talkers. The critical part is just to focus on narrowing the amount of potentially applied gain and refining your detection and response timings inside the block. That's the really critical part. So I'm going to show you AGC and then we'll move on to CAC. So I'm going to show you, well, I guess first thing I'll show you, this is how AGC would sit in the chain if you're using it on the input side, which is typically where it's going to get used. This shows you where it would be, you know, do your other processing and then let the AGC see the signal. All right. So what you're seeing here, this is actually a speech track that we're looking at. Our signal is sitting below the threshold. So we are applying gain. Now, it is set to where it will only allow 4 dB. So you'll notice that once this signal, as I turn it down, once this signal gets down here, and we've got our recovery turned on, so we have to wait. I'll turn the recovery off and you can see it happen a little bit faster. Well, now we're below the threshold. Isn't that the way this always happens? Anyway, you'll notice that this will never go above 4. So because of the settings we've given it, we've told it that we want it to only start working at -30. Maybe that's my problem. I'm below my target, or I'm below my threshold. We only want it to operate between -30 and we want it to stay at -15. So I'm going to turn this recovery back on and I'm going to turn this up. So now I've got somebody that's really talking loudly in the room. Probably me getting on a microphone because I have a big voice. So you'll notice that as I turn this up and as this person gets louder and louder and louder, you'll notice that we have gone from applying gain to now we are taking gain out. We are smoothing that person out a little bit and we're taking some gain out. So you'll notice on this, see there, now you'll notice that we've gone beyond 4. So this just is about how much we can add. It has nothing to do with how much we can take out. If this person gets a ton of gain. So I'll switch over on the music side and now you can really see it. So this is a little bit more of a steady signal. So as we turn this down and as we let our recovery hit, you'll notice that as we get to about a 0 dB, that this is doing its job. It's trickling in and above, and we're watching it change. So we've got our target, we've got our threshold, and now we're watching our AGC work. So Any questions on AGC? Again, my biggest thing to remember about AGC is it takes time to set it up. You will need to sit in the room and you will need to make sure through different situations that you have everything sounding the way you want it to sound. Don't let your AGC try to take big giant swings at the signal. You know, keep your threshold and your target in reasonable range, and then make sure that this maximum dB does not get out of control. All right, so that is AGC in a nutshell. So the last thing that we're going to talk about today is CAC. So this is continuous ambient compensation. For any of my fellow hospitality folks, this is fairly widely used. I used to use these in casino and hotel applications, as well as some sports bar applications. So the continuous ambient compensator, what makes it special is that it has a microphone in the room, and it is sensing background music it's sensing background noise, filtering out the music. So similar to the way an AEC works, you actually get, you can see it right here. Continuous ambient compensator has 3 things that you feed into it: program material, the microphone itself, material going through. This is our microphone that we've got in the room, and then this is a reference signal. Just like when we set up an AEC reference, we want this is hearing what's coming out of the speaker. So it's going to go through, it's going to filter out that reference, and then use the level of the microphone input to adjust the level of the program material. So this one that we're looking at, this is the continuous ambient compensator. There's also one called a gated ambient compensator. It works in a similar way, but it does not have a reference input. This is generally used when you don't have any sort of like background music or anything like that. So if you're looking at an industrial application where you want to monitor the level of machinery on a floor and adjust a paging level, that would be more for a gating ambient compensator. But if you're dealing with, I've got a sports bar, and I want to make sure that if I get, or casino floors, these are used a ton on casino floors. As my casino floor fills up and more people are out there talking and the dealers are talking and everybody's having a good time, I want to raise my music level so that people can still hear the music or hear if I'm making announcements or anything like that. But if the floor is dead, I don't want to have my pit boss or whoever my floor manager is constantly running back and forth to a panel trying to turn the music and paging up and down. So that's an area where you would use that CAC to take care of that. All right, so we've got a couple of settings here, some basic settings that we need to set. Distance that the microphone is to the nearest speaker. This is critical because this has to do with setting sensitivity and how it listens for the signal that it's going to cancel out. If the okay, so detector time, we've already talked about detector time. Program cancellation, this is going to show you how much noise is being canceled out, or how much program material is being canceled out that it's picking up. We also have in our gain calculation, we have our ambient threshold. This is the recovered ambient signal level, at which point the compensator starts compensating. So this is kind of where this is our jump off point. This is the lower of these two dots, and this shows where we're going to start working. This needs to be above your typical background noise. This is where you want to start working. All right, so minimum gain, this is the lower edge of where we can go. This is the upper edge. So unlike the AGC, where we could go down as far as we wanted, but we could only go up to the maximum gain, we now have a minimum gain. This is also represented by this lower dot, in that this is where we start, this is where we end. We only operate in this space right here. And then we have our ratio as well, which is how we, you'll notice that this will level this out. This has to do with how much do we need to get above that to really start to get gain. This just goes from 0.2 to 2. This is a little bit different than our other ratio calculations, but the concept is the same. Typically, this is a 1-to-1. As we get 1 dB above our zero line, we add 1 dB of program. So that's how that works. Same things with attack time and release time. So the things that I will say when it comes to setting up a CAC, these really take some time to get right. You want to be very careful with your maximum gain, because you don't want to do what I used to call climbing the ladder. People come in, they start having a good time, they're talking, they're chatting, the music turns up because they've gotten a little bit louder. Well, now the music's higher, so I feel like I got to be a little bit louder to talk to my neighbor next to me, so I start talking louder. So now the system senses that they're talking louder, and it starts turning the music up again. And you can literally just sit there, and if you have that maximum gain too high, you will sit there and people will just climb this ladder all night. And by the time they're done, you definitely want to avoid this. So if you're setting this up, be very careful on your attack and release times, because if you're dealing with, say, our casino floor example, and you have that attack time set really fast, and somebody hits their number on roulette and the whole table cheers, yay! You don't really want to catch that. You don't want your system to jump up all of a sudden because those people cheered and then they stop cheering and everything jumps back down again. So you'll get this weird pumping noise if you have those set too fast. Again, my recommendation, put one of these in, start slow and low. Start with real short minimum and maximum gains. Start with some fairly long attack and release times and detector times, and then just watch the block. It's perfect. It still gets you pretty close, especially if you're dealing with high traffic areas and large open spaces where you want to be able to automatically adjust levels based on that ambient noise in the room. So I'm going to show this. Now, again, speaking of imperfect things, this example is imperfect because I am faking every bit of this. But this just kind of shows you how the block works. So I have this detector. I have just some crowd noise that I've got fed into it. This is simulating my background crowd noise. What I want you guys to see is I want you to just watch this block, how it works. My crowd noise is ambient threshold, which is at -22. So I am pumping gain into this, but you will notice that it is capping off at 5. Even though my signal is really high on my background input, now you'll notice as this drops off, because I've got these attack and release times set, it's going to have to drop way off, but now you're starting to see it slowly come back down. So again, The CAC, a lot like the AEC block, it actually takes time to converge. So because of the way I do this demo, where that CAC block doesn't see anything for periods of time, when you first fire it up, it may take it, and so give it some time to do a little bit of learning, start working on it. Okay, where is my ambient threshold really? Where do I want my minimum and maximum gains to sit relative to my room gain? How fast or slow do I want it to either detect or attack and release? Those are all things that you will play with and tweak. They'll take some time. You'll need to sit in the room and listen to it, talk to your customers. How loud do you want this to go on its own? How quiet do you want it to go on its own? And those are all things that you'll work with them and dial this in. But I will say, just like a well dialed in AGC, a well dialed in CAC is a huge asset for a system. And people will think that you are working some kind of just wizardry when it comes to setting these up. So that pretty much concludes my demos here. I will stop sharing for a second. Again, thank you guys so much for being patient with me today, and while I had my little hiccups and my issues. If anybody has any questions, please throw those in. I realized that I did this entire webinar with my name as QSE Webinars. I'm going to put my name in here only because if you guys ever have any questions, you are always welcome to reach out to me. First name dot last name at qsc.com. So I'm steve.mccary at qsc.com. Thanks for bearing with me. I know we're about 5 minutes over time. Some people have to run. We'd have been right on time if it hadn't been for my pesky internet issues. I know I sound like the villain at the end of every Scooby-Doo episode, but that's where we are here. So I will stick around for another 2-3 minutes in case anybody has any questions for me. Otherwise, you guys will receive a copy of this file and the PowerPoint. The PowerPoint that you'll get a copy of is actually more than just what I showed you. All of a bunch of my notes from when we were actually in the file are in that PowerPoint that you'll get. So some of the little details that I went over as far as what the individual pieces or what the individual controls do inside the blocks, that's actually all spelled out in the PowerPoint that you guys get. I use it as a little script as I'm going through, but then you guys can have it to use if you ever needed to go back and reference it later on. So thank you guys for attending and coming out. I appreciate your time. I will let you guys go and get to your day. We will be back next week with, I can't remember what. I should probably be better at knowing what it is that we're doing. But yeah, we'll be back next week. We'll be back Tuesday at 10 a.m. Central, 8 a.m. Pacific, 11 a.m. Eastern, wherever you are in the world. So have a great day. Thank you again for joining us, and we look forward to seeing you guys next week. Bye-bye.